Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be taking a look at how to graph linear equations in standard form. We're going to be graphing linear equations in standard form using the intercepts method. Don't forget, we have some practice problems at the end of this presentation, so be sure to watch the entire presentation and try out those practice problems so you can demonstrate mastery of the contents of this tutorial. Alright, to get us started, let's take a look at the steps that are going to be guiding our problem solving process. So if you want to graph the equation of lines in standard form, these are the steps that you're going to follow. Okay, so step number one, just make sure that the equation is in standard form. Okay, make sure that the linear equation is in standard form. Okay, what is the standard form of the equation of the line? The standard form of the equation of a line is ax plus by equals c. Basically have the variables all on one side and the constant on the right side. Okay, and then after that, you're gonna find the intercepts. You start with the x-intercept, so you find the x-intercept by setting the other variable to 0. So by setting y to 0, you find that x-intercept. So you find the x-intercept by setting y to 0 and solving. For x. That will be your x-intercept. Alright, and then after finding your x-intercept, you're going to proceed to find the y-intercept. So you find the y-intercept by setting the other variable, namely x to 0. So by setting x to 0 and solving for y, that will be your y-intercept. Now that you have your two intercepts, you're going to graph the intercepts on the axis. Alright, the x-intercept is graphed on the x-axis and the y-intercept on the y-axis. Now you have 2 points that define a line, and you just simply connect the intercept points with a line, and you're in business. Okay, so let's go ahead and apply these steps in graphing the equation of lines in standard form. Okay, so the instructions for the examples that we're doing are for us to graph each linear equation using intercepts. Okay, so for number 1, let's say we have the linear equation 2x minus 3y is equal to negative 12. Alright, so let's graph that. We're going to be using the steps outlined. Moved it to the right side. So if you have 2x minus 3y is equal to negative 12. Now, what form is this? This is already in standard form, okay? Because you notice the x and the y is on the left side. You have the x term first, the y term second, and then the constant is on the other side. So this is known as the standard form. Alright, the standard form is the ax plus by equals c form. So step 1 is already taken care of. All the examples we're doing today are going to be in standard form. Alright. Okay. Next then, we have to find the intercepts. We'll start with the x-intercept. Okay. So we're going to find the x-intercept. How do you find the x-intercept? To find the x-intercept, you're going to have to set the other variable to 0 in the equation and solve. Okay. So set y equal to 0 and solve. So notice the equation. We have 2x minus 3y. So it's going to be 2x minus, instead of 3y, it's going to be minus 3 times 0. That's what it is to set y to 0. And then solve the resulting equation. Okay. So you have 2x, 3 times 0 is 0, equals negative 12. All right. And then we have 2x is equal to negative 12. You can just drop the 0. And then to get x by itself, you divide both sides by 2. Okay, and then you get x equals negative 6. Guess what? This is your x-intercept. So our x-intercept is negative 6. What does that mean? It means that we're going to graph the point. Notice we have the x-coordinate, which is negative 6. And what's the y-coordinate? Remember, we set y to what? 0. Negative 6, 0. Okay? All right, now let's go ahead and do the next one, which is to find the y-intercept. Remember that 2 points define a line, okay? Minimum of 2 points. We already have the first point, so we need to find the second point using the y-intercept. So to find the y-intercept, we're going to set x to 0 and solve. Doing the same thing, but we're switching coordinates now. Okay, so we have 2 times 0 minus 3y equals negative 12. Okay, what happened here? We just replaced the x in the equation with 0. Now we're going to solve that. 2 times 0 is 0. 0 minus 3y is negative 12. Okay, and then we can drop the 0. Negative 3y is equal to negative 12. And then divide both sides by negative 3 to isolate y. Okay, and then you get y equals 4. What is this? This is your y-intercept. So your y-intercept is equal to 4. And that just basically means that we're going to be graphing the second point, 0, comma 4. There goes your y-intercept. All right, so let's go ahead and graph the line, which is step 4 on our steps list. So let's draw our coordinate system first. There goes the y-axis. And then let's do the x-axis. Right there. All right. So we're going to grab the intercepts on the axis. Okay. So this is your y-axis, the vertical axis, and this is your x-axis, the horizontal one. So your x-intercept is negative 6, 0, which is right here. 1, 2, 3, 4, 5, 6. This is negative 6. Okay. So we'll grab this point. Negative 6, 0 is your x-intercept. All right, and then you graph your y-intercept, which is 0, 4. So 1, 2, 3, 4. This right here. Bam, that's your y-intercept. Okay, so we have our intercepts graphed. So we just simply do step 5, which is to connect the intercepts with a line. All right, so make it blue. Like that, bam, and there goes your line right there. That's the line of the equation that is given. Okay, so this is the line of the equation. 2x minus 3y equals negative 12. All right, so don't forget where intercepts are here. This one right here was our y-intercept. Is basically the point where the graph cuts or intersects with the axis. That's what the y-intercept is called. And this guy right here is the x-intercept. That's the point where the line intercepts or cuts the x-axis. All right, let's try another example. Question number 2. Let's say we have the equation x plus 2y is equal to negative 2. All right, we're going to follow exactly the same steps here. Solutions is as follows. So let's rewrite our equation. X plus 2y equals negative 2. So first, you're going to make sure it's in standard form. Certainly is. Notice that the variables are on the left side with the x term first and the y term second. Basically, the ax plus by equals c form. All right. Okay, now let's find the intercepts. First, we're going to find the x-intercept. To find the x-intercept, you're going to set the other variable y to 0 and solve. Okay, so we're going to have x plus 2 times 0. Okay, x was 2 times 0 is equal to negative 2. Bam, bam. All right, so we have x plus 2 times 0 is 0 equals negative 2. Basically, this term is gone. So you have x is equal to negative 2. What is that? This is the x-intercept. The x-intercept, the value of x where the graph cuts the x-axis, is negative 2. So we're going to be graphing the point negative 2, 0. Okay. Next, we're going to find the y-intercept. You need 2 points to define a line. So here we're going to set the other variable x to 0 and solve. Okay. So we have 0 plus 2y is equal to negative 2. Replace x in the original equation with 0. Okay, so when I have 2y is equal to negative 2, and then now we're going to proceed to divide both sides by 2 to isolate y. So that will yield y is equal to negative 1. So we're going to graph the point. Now we're going to be graphing our second point, the y-intercept, right? So let's specify what that is first. So this is the y-intercept that we just found. The y-intercept is negative 1, so that means we're going to graph the point 0, negative 1. Okay, let's do this. All right, so there goes the axis. So let's label them. This is your y-axis right here, and this is your x-axis. Your x-intercept is negative 2, 0, negative 2, 0, right here. Negative 2 value on the x-axis. This is a point where the graph intercepts or cuts the x-axis. Y-axis is 0, negative 1. It's negative 1 down here. So this is the point where the graph intercepts or cuts the y-axis. Okay? So we're going to go ahead and draw the line through the 2 points. Like that. All right, so that's the graph of the line. Let's specify our intercepts on there. So this is our this value right here is our y-intercept. So the y-intercept, and then this guy right here is your x-intercept. Okay. All right, let's go ahead and try another example. Now for question number 3, what if we have something like this, x equals 5? How do you graph something like that? Okay, this one is already in standard form. Okay, x equals 5. So let's find the x-intercept. So in this particular one, the x-intercept is 5. Because it's already solved for x. So we're going to graph 5, 0. What's the y-intercept here? There's no y-intercept. So y-intercept is none. So you're going to graph a line that never touches the y-axis, but goes through 5, 0. Okay? Okay, so let's graph the intercept 0, 5. The intercept, 5, 0 is right here. 1, 2, 3, 4, 5. So how do you draw a line that never touches the y-axis? So what types of lines never touch? In order to guarantee that 2 lines never touch or intersect, they must be what? Parallel. They must be parallel. Okay? So what we're doing is we're going to draw a parallel line to the y-axis, but goes through this 1, 2, 3, 4, 5 x-intercept right here. So the result will be a vertical line. All right. So that right there, so let's write out this our x-intercept, which is 5. This is a line of the equation x equals 5. It's a vertical line, a line with undefined slope. All right, let's try one more example. For question number 4, let's say we have the line y equals -2. Okay, so this equation is also in standard form already because you have the variable on the left side and a constant on the right side, even though it's just one variable. So in this particular case, let's find the x-intercept. In this equation, there are no x's, right? So your x-intercept is none. The line never touches the x-axis. And then how about your y-intercept? It's already solved for y, right? So your y-intercept is -2. So we're going to graph the point 0, -2. And the line will be constructed in such a way that the line never touches the x-axis. Because in this particular problem that we have right here, there are no x-intercepts. So we have to ensure that that's the case. Okay, so let's draw our coordinate system. There goes our y-axis and our x-axis. Okay, and let's label it. This is your y, and this is your x. Now we're going to go ahead and graph the y-intercept 0, -2, 1, 2. Bam, right there. Okay, so now this is the goal. We're going to draw a line that goes through the point 0, -2, but never touches the x-axis. So a line that never touches the x-axis and goes through this point will have to be a line that's parallel to the x-axis. It's going to have to be a what type of line? A horizontal line. So it's going to be a horizontal line right here. Since it's parallel to the x-axis, we know for certainty that it is not going to intercept the x-axis at any point in the real number set. Okay, so this line right here is the line y equals -2, and this point that we just graphed is your y-intercept. Okay, so that's how you graph lines in standard form.